Okay, in this video I want you again, as usual, to read the intro into this section, but I'm going to focus mainly on showing you how to find the inverse of a square matrix. Now remember, when you read this you'll find out that matrices of these forms are actually called identity matrices. So they're not the same as the identity for real numbers, but they're similar, but they're for matrices. For real numbers, the identity is 1. So it's kind of like these are the ones for matrices. But it depends on the size of the matrix we're dealing with, on what size the identity is going to be. So let me show you how to find, after you read this, read this, then get down here to the instructions on how to find the inverse of a square matrix. We're actually going to go back to augmented matrices with this application. So first of all, if I ask you to find the inverse of this matrix, you're going to take this matrix and you're going to augment it with the 2 by 2. Since that's a 2 by 2 matrix, we're going to augment this with the 2 by 2 identity matrix, 1 0 0 1. And then we're going to do row operations until we get to this step where on the left I have the identity matrix on the left. So it's going to be done just like we're trying to solve a system of equations like we did before, so that we can get the left hand side in reduced row echelon form. Alright, so let's go ahead and start. So if I was wanting to get this side in reduced row echelon form, remember the first thing I want to do is get a 1 right here. So to do that, I'm going to multiply everything in row 1 by a third. So a third times 3 is 1, a third times 1 is a third times 1 is a third times 0 is 0. Then after that, I'm going to use the 1 to eliminate the 4. So I'm going to do minus 4 times row 1 and add it to row 2. And I'm going to put the result in row 2. So minus 4 times 1 is minus 4, plus 4 is 0. Minus 4 times a third is minus a third, plus 2. 2 is 6 thirds. So minus a third plus 6 thirds. Let's see, minus 4 thirds, excuse me. Minus 4 thirds plus 6 thirds is 2 thirds. And then minus 4 thirds plus 0 is minus 4 thirds. And then minus 4 times 0 is 0, and 0 plus 1 is 1. Okay, the next thing I want to do is I want to convert this to a 1 by multiplying this row by the reciprocal of 2 thirds. So I'll just multiply everybody by 3 halves. So 0 times 3 halves is 0. 2 thirds times 3 halves is 1. 3 halves times negative 4 thirds. You can do that on scratch paper if you need to, but you're going to get negative 2. And then 3 halves times 1 is 3 halves. So there's my new row. Now I've got the 1. Now I want to use that 1 to eliminate the 1 third. So I need to multiply row 2 by negative 1 third, and then add it to row 1 and put the result in row 1. So negative 1 third times 0 is 0, plus 1 is 1. So, and then let's get this out of the way. And then negative 1 third times 1 is negative 1 third plus 1 third. That gives me 0. Then negative 1 third times negative 2 is positive 2 thirds. And 2 thirds plus 1 third is 3 thirds, which is 1. And then negative 1 third times 3 halves. Let's see, the 3's would cancel, so you would get negative 1 half plus 0 would be negative 1 half. Well, now that we've got the left-hand side in reduced row echelon form, where we have the identity over here, so remember that's the identity. Once we get the identity over there, then this side over here must be the inverse of the original matrix. So the inverse would be these 4 elements here, and so let's make sure we identify and show that we know the inverse is that 2 by 2 matrix. And you can check it by multiplying the original matrix by the inverse to check to make sure that when you multiply them together you do get the identity matrix 1 0 0 1. And there's you a practice problem you can practice on. Now I realize the calculator will let you cheat and hit the inverse key, but you really need to learn how to do this using row operations, because many professors will not let you do this any other way. Okay, on this page I have a couple of 3 by 3 matrices that I find the inverse of, so I don't think there's any reason for me to do both. So let me just do this second one here. And if you look at the first one, I did duplicate some matrices in certain places, but on this one I don't. I don't think I do anyway. You want to find the inverse of this 3 by 3 matrix. Remember, it's got to be square for it to have an inverse. So I'm going to take this 3 by 3 matrix. Now, so here's the matrix A, right? And I'm going to augment that matrix with the identity matrix of the same size. So now I've got to use a 3 by 3 identity matrix. Now, what I want to do is I want a 1 right here, which I already have. Remember, I want to get this left-hand side in reduced row echelon form. So I've got a 1 here. I've got a 0 here, so that's good. But I need to get rid of this 2. So I'm going to have to do minus 2 times row 1 and add it to row 3. Well, minus 2 times 1 is minus 2, and then minus 2 plus 2 gives me 0. Minus 2 times minus 1 is plus 2, and plus 2 plus 3 gives me 5. Minus 2 times 1 is minus 2, and minus 2 plus 0 gives me minus 2. Minus 2 times 1 is minus 2. Minus 2 plus 0 is minus 2. Minus 2 times 0 is 0, and 0 plus 0 is 0. Minus 2 times 0 is 0, and 0 plus 1 is 1. Okay, so now let's see where we're at. I've got to drop down to the next row, and I need my leading coefficient here to be a 1. So I'm just going to multiply this row by 1/2. So if I multiply everything in here by half, that would be a 0, 1, negative 1/2, 0, 1/2, 0. So there's my new row. Okay. Now I want this 1 so that I can use it to eliminate the negative 1 above it and the positive 5 below it. Well, to eliminate the negative 1, I just got to add row 2 to row 1. So let's do that. 0 plus 1 is 1. 1 plus negative 1 is 0. Negative 1/2 plus 1 is 1/2. 0 plus 1 is 1. 1/2 plus 0 is 1/2. And 0 plus 0 is 0. Now to get rid of the 5, I need to multiply row 2 by negative 5 and add it to row 3. So let's do that. Negative 5 zeros plus 0 is 0. Negative 5 times 1 is negative 5, plus 5 is 0. Negative 5 times negative 1/2 is 5 halves. 5 halves minus 2 would be 5 halves minus 4 halves, which is 1/2. Negative 5 times 0 is 0, plus negative 2 is negative 2. Negative 5 times 1/2 is negative 5 halves, plus 0 is negative 5 halves. Let's see, it looks like I missed a sign here. Okay, and then negative 5 times 0 plus 1 is 1. And so now I've got to get to this third row, and now I need to make that a 1. So to make this a 1, I'm going to multiply this row by the reciprocal, which is reciprocal of 1/2 is 2, so let's multiply by 2. 2 times 0 is 0, 2 times 0 is 0, and 2 times 1/2 is 1, so this will be 0, 0, 1. Then 2 times negative 2 is negative 4. 2 times negative 5 halves is negative 5. I've corrected that. 2 times 1 is 2. Okay, and now I want to use row operations here to eliminate this 1/2. So I'm going to multiply row 3 by negative a half and add it to row 1. Well, negative a half times 0 plus 1 is 1, and negative half times 0 plus 0 is 0, and negative half times 1 is negative half plus a half is 0. And then negative a half times negative 4 is 2, and 2 plus 1 is 3. Negative a half times negative 5 is 5 halves. 5 halves plus 1 half is 6 halves, which is 3. Negative a half times 2 is negative 1. Negative 1 plus 0 is negative 1. Then I want to get rid of the minus a half, so I'm going to multiply row 3 by plus a half and add it to row 2. So a half times 0 plus 0 is 0. A half times 0 plus 1 is 1. A half times 1 is a half plus negative half is 0. A half times negative 4 is negative 2. Negative 2 plus 0 is negative 2. A half times negative 5 is negative 5 halves, plus 1 half is negative 4 halves, which is negative 2. And then a half times 2 is 1, and 1 plus 0 is 1. And so now that I've got the left-hand side is the 3 by 3 identity matrix, I know the right-hand side of that augmented line is the inverse. And notice, I've got a negative 5 right here. So I had made just a little bitty error there that I'm glad I caught for you. And again, you can check that. I'll go ahead and finish out my time on this and just summarize the one that I skipped over for you. And then on the next video, I'll do the applications. So this is just like the one I just did. You just take this 3 by 3 matrix, augment it with the 3 by 3 identity matrix here. And then you have a 1 here, and I'm just going to summarize here. You just take row 1 plus row 2 to get a 0 here, and then of course it changes everything else. And then you take row 1 plus row 3 to get a 0 here, and then of course it changes everything else in this row here. And this one actually works out kind of nice, because not only do I have a 1 here, I've already got a 0 below it. So all I have to do, and notice I copied this down, I copied this same matrix down right here for you. But notice all I have to do is just multiply this row by 3 and add it to this row. And so if you do that operation, you're going to get a 0 here, and then of course some other numbers are going to change. So now I drop down to the third row, and boy, this one's working out real nice. Notice I've already got a 1 right there. I've got a 0 above it, so that's good. All I have to do is eliminate that 7. So let's just copy this matrix down here and work from here. So here's my 1. So I'm going to multiply this row by negative 7 and add it to this row. And when I do that, you can do the row operations yourself, but when I do that, I'm going to get a 0 here, and then it's going to change, some other values in this row. And now on this side, of course, I have the 3 by 3 identity matrix, and on the other side, once I get that 3 by 3 identity matrix on the left, I know I have that inverse on the right. And so let's identify our inverse matrix here. So that's the inverse of this matrix that we started with up here. And so that's pretty much it on inverses. I'm going to go ahead and throw in another video showing you a couple of applications of inverses of matrices.